All right, so we're going to look at strategies for graphing a rational function. So we're going to follow these 7 steps as we graph um, each equation that we covered in this video. So first things first, we want to determine whether the graph of this function has a symmetry. Okay, we talked about y-axis symmetry, we talked about origin symmetry, but as we do a question, I'll go back and refresh on that concept. Number 2, we want to find the y-intercept if there's one. Number 3, we want to find the x-intercepts if we have any x-intercepts. Then we're going to look for the vertical asymptotes, horizontal asymptotes if we have one, and then plot at least one point between and beyond each x-intercept and vertical asymptote. And then if we have to, number 7, use the information obtained previously to graph the function between and beyond the vertical asymptote. So if we have to create some more points, we'll do that just so that you can see or have a vision as to what the graph will look like. We want to graph f of x is equal to 2x all over x plus 3 using the 7 strategies that was discussed previously. Okay. All right. So first item on the list, we want to determine whether the graph has symmetry. So let's work this out algebraically to determine if it has symmetry. So remember, to determine if a function has symmetry or not, we're going to substitute negative x in for x. So wherever we see x, we're going to plug in negative x. So we have here 2 times negative x all over negative x plus 3. So this gives us negative 2x all over negative x plus 3. Now, to determine if this function has a y-axis symmetry, we want our our functions to match. So when we replace negative x in for x, I want this solution to look exactly like the original function, and it does not. So we do not have a y-axis symmetry. Now, to determine if it has an origin symmetry, every term needs to be the opposite of the original function. Every term. So this 2x needs to be negative. This x needs to be negative, that's in the denominator, and this 3 needs to be negative. And if you look at what we have here, yes, the 2x is negative in the numerator, the x is negative in the denominator, but our 3 remain positive. So because it's not the opposite of the original function, this function does not have an origin symmetry. Therefore, this function has no symmetry about the y-axis or the origin. All right, so number 2, we want to determine if this function has a y-intercept. And remember, to find the y-intercept, we let x equal to 0. So f of 0 equals to 2x over x plus 3. We're going to plug in 0 in for x, 0 in the numerator and denominator. We have 0 over 3, which is 0. So the y-intercept is 0, 0. Number 3, the x-intercept. We want to let y, or we can say f of x, equals to 0. So we would go back into our of original function. Where we see f of x, we're going to plug 0 in for that. So we have here 0 is equal to 2x over x plus 3. That, remember that that was our f of x. Now we can cross multiply because I can make this 0 into a 1, excuse me, place a 1 under the 0, make it into a fraction. And as we cross multiply, we have 0 times x plus 3. That would give us 0. And then we have 1 times 2x. That is 2x. And when we solve for x, we're going to divide by 2 to both sides and we get 0. So our x-intercept is 0, 0. So right now we really don't have that much information about this graph. So this is where we need to find some other points to be able to that we can use and plug into this function to be able to graph, see what the graph looks like and the shape of the graph. Number 4, we want to find the vertical asymptote. So I'm going to just write it as VA, representing the vertical asymptote. So to find the vertical asymptote, remember we set our denominator equal to 0, and our vertical asymptote is going to be a vertical line. And then number 5, step 5, our horizontal asymptote, we have f of x is equal to 2x over x plus 3. We're going to look at the degrees of the numerator and the degree of the numerator and the degree of the denominator. Our degree for 2x is 1 in the numerator, and our degree in the denominator is 1. So since our n and m are equal to each other, we have y is equal to, we're going to look at the coefficient of 2x and x. So we have y is equal to 2 over 1, which is 2. So we have y is equal to 2, this being a horizontal line. So let's at least draw the horizontal line, excuse me, the vertical asymptote and the horizontal asymptote. So let's do that right now. So vertical asymptote is at -3. So let's draw that. Parallel to the y-axis. Here is -3. Here is -3. And I'm going to draw in blue our vertical line, our vertical asymptote. Okay, so next let's draw the horizontal asymptote. Y is equal to 2, positive 2. Here's positive 2 parallel to the x-axis. And we do know that there's an x-intercept and y-intercept at 0, 0. Now, if we want to find some points, okay, then what we will have to do is let's go back to the original question, and we're going to plug some numbers in for x. So we need to find where this graph is going to connect. So one or two things, we can create an XY column, okay, or we can use our graphing calculator and find some points. Go to your y equals screen, type in the equation, place parentheses around the numerator and denominator, and let's find some points. Let's go to second and table, and let's find some points that we can plot. Look at -3. There's an error. That means that's an undefined. Um, at -3 is undefined. Okay. Um, all right. So let's find some points. Just for time's sake, we have some points here. I see -9, 3. We have -6, 4. -5, 5, -4, 8, -2, 4, -1, -1, 0, 0, of course. Let's do some positive numbers here. We have, let's see, 3, 1. Okay, we can keep going. Well, my graph doesn't go, it just goes up to 10. Okay, we can do 9 and 1.5. All right, so let's plot some of these points here. Okay. All right, so here we go. We have -1, -1. We have -2, 4. Excuse me, -2, that's -4. Let's change it on here. That's -4. We have 3, 1. We have 9 and 1.5. Okay, so as you can see, the graph gets closer and closer to the horizontal and vertical asymptotes, but it will not touch the asymptotes. And let's find some other points here. We have here -4, 8. We have -5, 5. We have -6, 4. We have -9, 3. Okay, so that you can see exactly what this graph looks like. And here's your vertical asymptote, that's in blue, the horizontal asymptote, which is in red, and then in green we have our points, our graphs. There we go.